All right. We're going to go into chapter 6, which is automotive measurements and math. So after this chapter, you'll be able to use both customary and metric measuring systems. Identify and use the basic measuring tools. Use decimals and metric conversion charts. Use basic math skills and use percentages and ratios. Right. There are two commonly used systems used in automotive shops. You have your customary or US customary. This is inches, pounds, feet, miles, things like that. So that's what we use in the automotive shop as far as US side. You will see metric as well, which is millimeters, grams, kilometers, things like that. So you have two different types of metric systems that are used in the automotive industry. You do need to be familiar with both. So customary was originally originated with sizes taken from body parts. That's why, you know, a human foot should be around about a foot. Yard is about the length of your arm, things like that. Metric systems, they use the power of 10 for all their basic units. Metric systems are a little bit nicer because all you have to do is move a decimal point to change from like millimeters to centimeters and things like that. Conversion charts help change the measurements from one system to another. There's plenty of ways to find it. Sometimes they're in the service manual. Sometimes you can Google it. Some phones have it. I think my Android, you know, it has it automatically on the calculator settings. So I'm not sure about iPhone, but I know my Samsung does. A decimal conversion chart finds the equivalent value for fractions, decimals, and millimeters. So if we need to change 3/8 into millimeters, or if we need to change, you know, 0.5 into a fraction, you would know 1/2 to change that. So it helps with that. All right. There's an example of a conversion chart. You can see there. There's an example of a decimal conversion chart. I couldn't translate these slides because they're pictures. So, all right. So measuring tools. Steel rule or a scale is used to make low precision linear movements or measurements. Sorry. Customary rule uses numbered lines to represent inches, uses unnumbered lines to represent fractions of an inch. Metric rule uses unnumbered lines to represent millimeters and uses numbered lines to represent centimeters. So 10 millimeters is 1 centimeter. So, for example, this isn't a steel rule, but this is a ruler. You can see, if it'll let me, no, won't let me. You can see your measurements there, your numbers there, that's your metric. And on this one, it also has standard in inches on the other side. Usually it's like that. This is a nice one with the calculator on it too. So, a steel rule is just a metal ruler is all. All right, a pocket rule. This is a ruler that is about 6 inches long. That way it can fit into your pocket. Combination square, there's an example of this in the textbook. Essentially, it has a steel rule and it has a device on it that perpetrates about at 90 degrees. And these are used for usually used in carpentry and stuff to find in angles, because you can use it to figure out 90 degrees and 45 degrees and help you with measurements, especially when you're having to combine boards together and things like that, joining certain things at certain angles. Tape measure extends to several feet or meters in the length. Yardstick or a meter stick is used for large linear measurements up to 1 yard or 1 meter. A meter is just over 1 yard, so they're very close to each other. Meter is, I think, just a little bit, like that much more than a yard, just a little bit. All right, so calipers. This is known as a veneer caliper in this picture. This is used to make inside, outside, and depth measurements. So you can see here, this is for your outside measurement here. So you'll clamp it around whatever you're trying to measure. Give me just a second. All right, I'm back. All right, so you'll clamp this on the outside of what you're trying to measure. It'll give you measurement. On the other side right here is your inside measurement. So those are going to spread apart so you can measure on the inside of something. And down at the bottom here, that is your depth gauge measurement. So as this opens up, this will come out the bottom so you can measure how deep something is. There we go. Right, micrometers. These are used to make very accurate measurements. They're down to 1/10,000th of an inch, so 0.0001 inch. In metric, the metric ones will go down to 0.001 millimeter. Outside micrometers are for external dimensions, diameters, and thicknesses. This is a picture of an external or outside micrometer to the right there, and there's on the screen. Right, inside micrometers, this is for large holes, cylinders, or part openings. That's the picture on the left at the bottom. And depth micrometer. So that's the picture on the right. This is for measuring how deep something is or of an opening is. So reading a micrometer, this can be kind of tricky at first, but once you get the hang of it, it's very simple. You'll note the largest number visible on the screen. So over here, this will be 1. You'll count the sleeve gradations lines on the right. Note the thimble gradations, round off if you have to. Add all decimal values, add any full inches. Metric micrometers are the same way. So here's an example here down at the bottom. Follow me, Will. So you can see 1 here. This is 0.1. And then we will measure our gradations here. These are 3/4, or sorry, these are quarters of an inch, or quarters of this 1. So 0.1, you have 1, 2. I'm trying to think how they got 75. It should be 0.5. So you'll count those and add them up, 70. So they're saying there's 3 there. The picture's kind of bad. So if there's 3 gradations there, so that will be 0.075. And then we have 0, 1, 2, 3, which is 0.003, which you'll have to add all those together, which is 0.178 of an inch. Like I said, it's kind of confusing at first, but once you get the hang of it, it becomes very easy, very simple. Just remember these whole numbers here is point whatever that number is, like this is 0.1. These are 0.025, these lines here, each of them. And then each number here is 0.001, 0.002, 0.003, 0.004, 0.005, etc., so on and so forth, like that. and then you would add them together. And so whatever this line, you can see here, this line running through the middle lines up with on the thimble there, that's the number that it's being used. All right, so never drop or over tighten the micrometer or caliper. You want to store them where they cannot be damaged. Grasp the micrometer frame in the palm. Turn the thimble with your thumb and finger. Also hold it squarely with your work. You don't want it caught at an angle or anything. Rock or swivel the micrometer as it is touched on the rounded parts. That way you make sure you're measuring the right spot. Place a thin film of oil on the micrometer and caliper surfaces during storage. This will prevent it from rusting. Always check for accuracy using a standardized gauge block after dropping or prolonged use. You do have blocks that are calibrated to a certain measurement, so you'll use your micrometer to measure it, and whatever the measuring is on the block, you can figure out how accurate your micrometer is. That way, if you have to add a little bit or subtract it to get the correct measurement, you know how much to do that by. Feeler gauges. These are used to measure small clearances or gaps between parts. Flat feeler gauges are precisely ground steel blades, various thicknesses. So they're just pieces of metal, thin sheet metal essentially, and they're different thicknesses, and the size is written on each of those blades. They can be in hundreds of an inch, thousandths of an inch, they're written in thousandths of an inch and hundredths of a millimeter. So you'll use those, you'll slide them in the gap you're trying to measure. Whatever has a slight drag, that's your measurement. You'll read whatever measurement is on that blade, and that's your measurement. Wire feeler gauges are precisely sized wires labeled by diameter of thickness. These are used to measure slightly larger gaps in spaces. So flat feeler gauges only go up but so high, and then you get the wire feeler gauges, which are a little bit thicker. Usually feeler gauges are used for like crank position sensors, spark plug gaps, things like that. Right. Dial indicator, this measures part movement in the thousandths of an inch, hundredths of a millimeter as well. Used to check gear teeth backlash or clearance. So when gears rotate against each other, they have a little bit of clash to them, so they can move slightly between each other. So you can measure how much that movement is with the dial indicator. This is called your backlash. Shaft in play. So that's if a shaft moves forward or back or something. And cam lobe lift. So when we learn about engines, you'll learn about camshafts, how that works. So you'll understand that a little bit later on. There's a picture of your dial indicator there. I'm sorry, I thought I adjusted this picture. But anyway, words aren't too important because I'll just tell you what they say anyway. You'll mount the indicator securely, position the dial plunger, partially compress the dial plunger, lock it in place, move or rotate the part, read the indicator, and subtract the lowest reading from the highest. Okay, so what it's saying is when you set this up, the plunger here, you want that to be depressed slightly. That way, as you spin the part, if it has a lower section, it can go down and you can read that measurement on the indicator there. So there's a few different ways you can connect it. This one has a magnetic base and this flexible arm that will lock into position and hold it still. And as you spin it, that plunger will move up and down, and that will turn the dial. And so you can read your measurements, how much it is moving. Angle measurements. Circled as divided into 3 equal parts called degrees, abbreviated using DEG or that little circle right there. The parentheses aren't part of it. It's the little circle right here is all it is. 1/4 of a circle equals 90 degrees. Half of a circle is 180, 3/4 is a 270. You know, so there's different degrees and things like that. Temperature measures using temperature gauges or thermometers available in either Fahrenheit, capital F, or metric is Celsius, which is the capital C. You'll only see it normally under Celsius and Fahrenheit, unless you become a scientist, then you'll use another measurement, which is called Kelvin. But unless you're actually dedicated in that field, you pretty much will never see it anyway. Celsius and Fahrenheit is mostly what you're going to just see out there. Torque wrenches are used to apply a specific amount of turning force to a fastener. You can read them in foot-pounds, FT-LB, or Newton meters. So in the picture got a little messed up. There should be a dot there. So it's N.M. Those are your two. So foot-pounds is your customary standard. Newton meters is going to be your metric. You have multiple different types of torque wrenches. Down in those pictures give you your different types. You got your flex bar on your left, dial indicator in the middle, and your ratcheting or snap style torque wrench on the right there. And pressure gauges is used to measure air or fluid pressure. Pounds per square inch is your customary US measurement that you're going to use, PSI. Kilograms per square centimeter, kg/centimeter squared. And kilopascals, kPa, is your other that you're going to use, your other metric one. Kilograms per square centimeter is also metric as well. Usually you see a PSI or kPa. The middle one there is a little bit long to say, so a lot of people aren't going to use that one. Vacuum gauge, used to measure negative pressure or vacuum. Inches of mercury, IN/Hg. Hg is the periodic table lettering for mercury, so that's why it's like that. Metric kilograms per square centimeters. So metric is kg/centimeter square. Again, that's kind of a long word to say for a measurement. So even like everywhere you go is going to use inches of mercury most of the time. You probably won't see kilograms per square centimeter. That's it's just kind of long-winded to say. Telescoping gauge measures internal part bores or openings. And a hole gauge measures very small holes in parts. Auto technicians work with whole numbers, fractions, and decimals every day. You have to calculate measurements, clearances, part prices, labor charges, tax percentages, and total charges. So you have to work with math every day in the automotive field. There's a lot that involves with it when it comes to measurements, conversions, things like that. When I do AC, when I was doing AC work, I had to do a lot of different conversions, figuring out how much refrigerant I had to put in the vehicle because the vehicle specification was different sometimes than what the machine read. And so I have to do a conversion or something like that and do some math to figure it out, and things like that. So I'm not going to get into the rest of the slides because it's explaining basic arithmetic, which you should already know. I'm sure you already know addition, subtraction, multiplication, division, and those things. So I'm not going to go on with the rest of the slides. We'll end it right here on this presentation because this is mainly all you need to know as far as this lesson goes. So if you have any questions, get with me. I'll be sure to answer them or figure them out for you and things like that. Make sure to check the other videos on the playlist as well. I have a whole bunch up there that will help you figure out things as well.